Mm. All right, welcome everyone. Going to give folks a few moments to join, and then we'll start off with a quick intro before we get into today's webinar topic on fire retardant treated wood products. Today is presented by Travis Hixon. He's the technical manager with Koppers. Very excited to have him here today to be sharing some more about this very important product. All right, looks like we've got a good amount of folks in the door. So I'm going to go ahead and give a quick little introduction about some resources for after today's webinar, a little bit about what to expect once you leave today's webinar, and then we'll go ahead and get started. All right, so everyone who's on this webinar today has a free Acelab account. I'll share some resources in the chat momentarily if you want to connect with our team, get a free demo, learn some more about using this for your research. You can sign up for a quick meeting and we'll get you all set up. Few things I just want to show you quickly today. If you're looking for some more information after today's webinar, you can always use the search bar at the top, type in the name of any category, any product, any brand that you're looking for, and go on over to their page on Acelab. This is a great place to come after today's webinar if you're looking to connect directly with Travis, ask some questions about the products, get some more information or connect about a project. Then you can also scroll down here to view some more information about the company, their values, watch some great videos, and then explore their products, save it to your projects for future reference. So I'll share a link to this in the chat as well if you're interested in coming back here for some more resources and information after today's webinar. One more thing to show you here, I just want to quickly mention the conversation feature. So Acelab also works as a place to connect with building product reps. We'll give you the option during today's webinar to let us know if you're interested in connecting with Travis. And if you say yes, we'll go ahead and create a message for you in your Acelab account. You'll get an email about that. You can also log into Acelab and check this icon over here to head over to all your conversations. You can respond directly to the email notifications that'll log in Acelab's platform as well. So you don't need to open this, but can be a great place to come and just get an overview of all your communication through the platform. All right, last thing from me here, also want to quickly mention our firm library feature. So this is a really helpful way to save and store your product information. If you're interested in getting some help from Acelab's team and getting this all set up, let us know. And we will be able to help you get all of your historical information uploaded to your digital firm library. But just wanted to kind of quickly show folks this. It's a great place to keep your rep information organized along with product information. You can pull in data from Acelab's platform, and you can also add in your own custom data. It's collaborative, so you can share it with your team, add notes, all of that good stuff. So keep your eye out in the chat for a link to set up a meeting with my colleague Evelyn. And if you need anything else, feel free to reach out to me directly. I can shoot my email in the chat as well. All right. Other than that, just want to really encourage folks to ask questions throughout today's webinar. We should have some time to get to those at the end. If we don't get to your question live, we'll have a record of that and we can follow up with you after today's event. All right, that's it for me for now. Travis, whenever you're ready, feel free to go ahead and get started.
All right. Thanks, everybody, for attending. So I do work for Koppers Performance Chemicals. I handle a variety of things, but my primary activity is building codes and testing standards work. So that kind of dovetails into the fire retardant treated wood product because it's code driven and there are a lot of testing and other things that affect the product that need to be monitored, adjusted, things of that nature. So what we'll do today is talk about fire retardant treated wood, go over quickly the process by which it's manufactured, which is pressure impregnation. We'll talk a little bit about how it's addressed in the building code. Then we'll go through, and I think everybody here has a good handle on the 5 types of construction defined in the code, but we'll talk a little bit about how fire retardant treated wood is used in each of those types. And we're going to focus a little bit more on type 3 multifamily than the others. We'll look at some wall systems, and then we'll kind of finish up with some quick photos of what it looks like used in projects. And then at the end, I'm going to talk a little bit about coated products, that not pressure impregnated products, and why those aren't building code compliant. And at the end, I'll share my cell phone and my email address. So I encourage everybody on this, if you have code questions, that you don't think of today, or you have basic questions about treated wood in general, preservative or fire retardant, feel free to reach out to me. I'll be glad to be a resource for you. So with that said, we'll get started. Most everything I'm going to talk about today will be something that is addressed in or comes from the International Building Code and somewhat the International Residential Code. I'm kind of focusing on the 2021, but most everything in previous editions is roughly the same when it comes to fire retardant treated wood. If there's something you're confused about, just again, ask a question or feel free to contact me afterward. Testing and certification. I'm showing a bunch of logos here, some things you may recognize and you may not recognize. But the point I want to make to you is this: a product like fire retardant treated wood, one, again, is code driven. So if you have to have it, you have to have it. Most people are not going to buy it and use it by choice as an upgrade, let's say in residential framing. It's going to be something that's mandated for use by the code. And in the building code, to be fire retardant treated wood, there's a lot of language about third-party follow-up service, which is inclusive of the manufacturing of the chemical, all the way through to the treating and drying of the product, and then the labeling of the product. So the point I'm making here is it's heavily regulated. It's not something that I can just go mix up in my garage, hose onto a piece of lumber or plywood, and then sell as fire retardant treated wood and assume or basically decide that it's code compliant and everything will be fine. That is not the case. In addition to all the testing and certification, we have code compliance reports that prove that it's building code compliant for fire retardant treated wood applications. I'll mention some of these as I move through the presentation, but again, I just want everybody to kind of have in their heads that this is a heavily regulated, highly certified product. It's been in the building code and addressed for a lot of applications for at least 4 decades. And again, it's not something that we can just mix up in a garage, spray on a piece of wood. And at the end of the presentation, you'll understand why I'm saying that. All right, so what I want to do again today is give you an understanding of the pressure treating process. And I'm harping on pressure impregnation for a reason, and I'll show you the code language later, but for fire retardant treated wood applications, a product needs to be pressure impregnated, with one particular exception that we'll talk about later. I'm going to give you an idea of how fire retardant treated wood works, meaning what it does when it's exposed to a fire. Again, we'll talk a little bit about where fire retardant treated wood is used or allowed for or in construction, and then we'll talk about how you identify code compliant fire retardant treated wood. All right, what wood products can be pressure impregnated? This is an easy one, lumber and timbers. Everybody has seen this. So again, this is a pressure applied process similar to the way you'd manufacture a deck board. So any species of wood that we have a listing or testing for, which would be any species that's available for use in construction in the United States, in either lumber or timber application. So in the South where I live, you could probably tell when I open my mouth, I'm from the South. That would be southern yellow pine. In the West, that would be things like hem fir, Doug fir, things that you see for use in construction in load-bearing applications. Engineered wood products. All right. To some of you, if you know a little bit about fire retardant treated wood, you're probably looking at those 3 photos and 2 of them are standing out to you. All right. So one of them is plywood. That's the probably lion's share of the fire retardant treated wood business in the U.S. It'd be things like roof sheathing or wall sheathing. So plywood is something that's been tested, been treated for decades. LVL, PSL, glulam, large pieces of engineered wood that are for use in load-bearing applications. Currently, not many of those have been tested and certified for use. I'm currently working on an LVL product with a large LVL manufacturer. One of my previous employers, Hoover, has an LVL product that's fire retardant treated. And then I've got in the queue a glulam product that I'll start work on probably next year. So those products will be available, certified, stamped, hopefully within a couple of years. All right, the pressure treating process itself. There's a video I can click, but because we only have about 45 or 50 minutes, I'm going to skip the video and go to this slide. So what we'll talk about is just the basics of pressure treating. So starting at the top left, let's imagine that we're looking straight down a cylinder and the door is invisible. You can kind of see that that grid is the stack of wood, or at least it's supposed to be. It's not the best cartoon. I'm not the greatest artist. I apologize for that. But in any case, you wheel untreated wood on a cart into a long cylinder. And these cylinders are anywhere from 10 feet long to 150 feet long, depending on the plant. And they're generally an average of about 8 feet in diameter. All right, so you close the door and seal the cylinder. You draw a vacuum, and what happens there is you pull some excess moisture that might be out of the wood, but you also basically pull some air out of the wood. So you make the cell wall, the wood springy. You then fill the cylinder with a treating solution. After it's full, you pressurize it. You then drain the cylinder. You draw another vacuum to pull excess moisture out of the wood. And at that point, you've got pickled wood. You wheel it out and you're done. Fire retardant treated wood also needs to be kiln dried. We'll talk about that in a minute. But there are two types of fire retardant treatments in the market, and I want to bring them up because it can be confusing, particularly for those of you that deal with type 3 multifamily structures where the exterior wall and the sheathing on that wall has to be fire retardant treated wood. We've got an interior type and an exterior type. The Flame Pro product that we're talking about today that my company manufactures is an interior type of fire retardant treated wood. So when we talk about the words interior and exterior related to fire retardant, we're talking about not where it is, or at least oriented or nailed up onto the structure. We're talking about weather protected as opposed to weather exposed. So an interior fire retardant formulation, it's a water-based formulation. It's mainly comprised of boron, nitrogen, and phosphorus. So those chemicals are water soluble. If that material was put outdoors, let's say on a deck, over time, the material that's pressure impregnated into the wood could leach out and diminish the fire retardancy of the product. So essentially, the interior products are meant for inside the building envelope applications. So underneath the WRB. So plywood sheathing that's nailed to the outside of an exterior wall, that's still an interior fire retardant treated wood application. With exterior fire retardants, people see the word exterior and assume they have to have that type of formulation on an exterior wall. Roof sheathing would be another example where somebody might think or misspecify an exterior fire retardant treated wood when an interior fire retardant treatment is really what you need. The interior formulations are a lot less expensive than the exterior formulations. An exterior fire retardant is essentially a polymer. So you're pressure impregnating glue into the wood and then putting it into a kiln to harden it. And the applications that you'd see that product used for are like what you see in that photo: a pergola, a deck, wood fencing, anything attached to a home in a wildland urban interface zone. If you happen to live or work or specify in one of those zones, that's where you'll see a product like this specified. There are two on the market. They've been around for a while. They're not my products. A previous employer of mine does make one, but one thing I want to point out to you, they're not wood preservatives. They're just fire retardants that will not leach out of the wood if they're put outdoors in full-time contact with the weather. So you need to either stain it, paint it, protect it, or you need to use a naturally durable species like Western red cedar or redwood. So that's another confusing thing, and that's why I brought these this slide up with these two. All right, fire retardant treated wood. If you look in the building code, you'll see a requirement for a flame spread of 25 or less, and you'll see a smoke developed index requirement of 450 or less. So a thing I want to point out to you is that if we look up the ASTM E84 test or the UL 723 test, those two tests are basically, and I'll show you photos of them in a second, but those are the tests where you take wood, put it into a vessel, burn it, and calculate the flame spread. If we look those test methods up in an ASTM manual, E84 and 723 will basically show a 10-minute test duration. To be fire retardant treated wood, the building code states that those tests need to be extended to a 30-minute test duration. So 30 minutes, 3 times the 10-minute duration for ASTM E84 or 723. ASTM 2768 is a new test method, which is essentially just ASTM E84 for 30 minutes. It's unique and developed only for fire retardant treated wood. Fire retardant treated wood is the only product in the building code you'll see where this test is extended to 30 minutes. And the idea is that we're going to use this product in non-combustible construction, sometimes in load-bearing applications. So we want to make sure that the product works very well and achieves a flame spread of 25 or less in excess of products that are just meant for paint on a wall, like interior finish in Chapter 8, which only require a 10-minute rating. All right, so here's the apparatus to basically do any one of those 3 tests. It's called a Steiner tunnel. All right, so if you're looking at this, and this is at Underwriters Laboratories in Northbrook. So if you ever go there and take a tour, they'll show you this particular apparatus. But what you're looking at, the photo on the left, it's got those 2 documents hanging down. That kind of box section on the far right at the beginning of the photo, inside that box is a fan and a burner. All right, and then basically the top of that box is a lid. And I don't know if you can see the windows. I'm at a disadvantage because I can't point to things. I like it when I'm out in front of people, but we'll live. All right, those windows allow you to see in the box. So during the test, you're able to view the flame front as it spreads down the material. And this will give you a better idea of what's going on here. So the photo on the right, if you look up to the top left of that photo, you'll see that lid hanging. It's basically pulled up by a winch and chains. So you load your test sample on the top of the box and it caps it. So below that plywood is about 24 inches of open space by 24 inches wide, and the burners are at the front. And what you're looking at on the middle and left photo are just test samples that we would basically construct and cut to test the material. So to conduct the test, you put the lid down. There's a channel around it you flood with water, so you seal the box. And you start the burner, you start the fan, and you start the clock. Then again, the test is for a 30-minute duration. This, let's see if it works, but this is me holding my cell phone inside the fan box. You're not supposed to do this, but I know the test operator pretty good, and he let me do it. And I'm showing you this to kind of drive home, let's see if it'll work, how destructive this test is. You don't want to be in that box. It's not a joke. It's not somebody holding a propane torch up to a piece of wood for a few minutes. You know, it's meant to really try to destroy that piece of wood. And let's see if it'll, there we go. All right, so this is what a test charge will look like after the test is over. All right, on the left-hand side, that's a plywood test, and you can see at the kind of first 4 feet, we've got some charring and burn through, which is pretty typical. In the center, we've flipped them over, and you can see there's charring, you know, a pretty good ways down, let's say on the right, that plywood sample. The flame spread calculation, or a flame spread index, is just a nonlinear number based on time and distance. So, you know, an X and Y axis, one is time, the other is distance. And based on how far we get combustion, not charring, down that piece of wood, we'll calculate that flame spread index. And again, if you want a detailed explanation of it, contact me after this and I'll give it to you. But the guy that's conducting the test, he's watching through those windows that we saw earlier for actual combustion to occur. So the point I'm making to you is this: it's a really destructive test. The chemical that's pressure impregnated into the wood is extremely effective. We got charring almost all the way down that right-hand sample, but we didn't get combustion more than 10 feet past the center line of the burners. All right, the test results are listed in the UL Product IQ database. So we've got specific data for Koppers Flame Pro. You'd see the same thing for other manufacturers. And I think everybody on this call probably knows how to get to the Product IQ listing database. If you don't, that's the website that you would follow. Here's what it looks like when you get there. And I want you to notice something. So this would be our listing for treated plywood. You see Douglas fir and southern yellow pine. Under the flame spread and smoke developed sections, you see FRS. That's a designation UL gives to a formulation that's so effective that both the flame spread and the smoke developed are less than 25. So again, I want to point something out to you. If you remember from an earlier slide, our maximum for code compliance on the smoke developed is 450. This formulation on these two products achieves a less than 25 smoke developed. So it's a very drastic diminishing amount of smoke. And here, this is what the listing data would look like for the lumber products that we've tested. And again, you see FRS all the way down. So we're one of the only formulations out there that achieves an FRS rating for everything we've tested. All right, how to identify fire retardant treated wood. If any of you have dealt with this product, you've probably noticed when you've gone to do a job site visit, when you looked at fire retardant treated wood, it's colored. Mostly it's orange or pink. That's a colorant that treaters introduce into the treating solution to basically make it visible so you can identify it and not mistakenly use untreated wood for fire retardant treated wood or vice versa. That is not a requirement for code compliance. And it's a way some of the sham products in the market, like spray-on coatings, will use to trick you. So I want you to keep that in mind. What is a code mandated way to identify it is a stamp. It has to be labeled, every single piece. And you can see in that list 1 through 8, there are a bunch of things that we have to have in the stamp, but to kind of show you what that would look like, this is a stamp blank. So it's not the actual stamp that would be on a piece of wood, but it gives you an idea of what needs to be there. So on the left-hand side, the brand or the logo for the fire retardant needs to be there. The treating plant and the location of the plant need to be there. The species of wood and the commodity needs to be there. So it would say Douglas fir lumber or Douglas fir plywood. KDAT number 4 is kiln dried after treatment. So I brought up earlier that fire retardant needs to be kiln dried after treatment. There's a mandate in the building code that lumber needs to be dried to 19% or less moisture content and plywood needs to be dried to 15% or less. All right, you may recognize those numbers. Those are just basically the requirements for moisture content for wood products used in construction. So that's where we're pulling those from. But again, we're pressure impregnating this stuff with a water-based solution. So we're making it soaking wet after treatment. So the most effective way is to kiln dry it. So that KDAT is a signal to a building official or an inspector that that product would meet that 15 or 19% requirement. All right, on the right-hand side, that empty circle that you see would normally have UL in it, Underwriters Laboratories. At the beginning of the presentation, I talked about all the certification that goes into a product like this. And it's in the building code that it has to be third-party certified, tested, and monitored at the treating plant. So all of that being done basically equates to UL allowing their logo to be put on the stamp as required by the code. So you'd see that. Below that agency name or logo, you might see an additional name. Some plants use somebody other than UL, for example, to monitor the kiln drying. UL monitor the treating process. Somebody like Timber Products or Southern Pine Inspection Bureau might monitor the kiln drying. So you might see another agency logo under where UL would be. And then obviously the flame spread of 25 or less. And if you have a building code compliance report, the process standard or the ESR report would be listed at the bottom. A lot of information is in the stamp. If any of it looks funny, if you're dealing with a product that you think may or may not be fire retardant treated wood, I encourage you to call somebody like me and email me or show me a photo of the stamp, and I can tell you very, very quickly if it's fire retardant treated wood or not. All right, there's some special product considerations with fire retardant treated wood. Storage. I talked about that 15% or 19% moisture content requirement. we want to keep this product dry. It's used in construction, in structural applications or in non-combustible types of construction. And you need to meet that dry content or that moisture content threshold. Storing it out in the rain is not a good idea. There's another issue, and that's mold. All right. Wood has wood sugars in it, which is food for a mold. We're also pressure impregnating it with phosphorus. I mentioned that earlier. So essentially, we're putting nitrogen and phosphorus into the plywood or lumber. So it's almost as if we're pressure impregnating it with fertilizer, which would be another thing that mold would like to have to eat. The other two things mold would need is adequate temperature and moisture. So if it gets wet, it's possible it can mold, and none of us want to see that. Fasteners, fire retardant treated wood, and this one's confusing to a lot of people. Unlike preservative treatments where the active ingredient is a metal, fire retardant treated wood doesn't consist of a product that's pressure impregnated using a metal as the active ingredient. Again, nitrogen, phosphorus, and boron. So galvanic corrosion is not as big an issue as it would be with a preservative treatment. It's no more corrosive, and I put this in writing a lot. The way I stated is fire retardant treated wood is no more corrosive to a fastener than untreated wood. So while you'll see recommendations for things like galvanized fasteners, which is just us being safe as an industry, just about every formulation out there will tell you that an uncoated carbon steel fastener would be okay. So just, again, keep that in mind. This is not preservative treated wood where copper is typically the active ingredient. All right, cutting and ripping. Plywood, you can cut it in any direction. You could even plane it to a thinner thickness if you wanted. I don't know why you'd do that, but you could. With lumber and timber products, you can end cut, you can corbel cut, you can make curves, drill holes. You can't center rip it or cut it down the length. A light sanding is fine. The issue is this, and I have to be careful how I state it with some people because they get confused or ask me why I'm stating it the way I'm stating it. But the actual reason that we can't do it is UL doesn't allow us to state that it's okay. We only test actual pieces of material that would be delivered in the way that they come from a mill and then treated. So UL states that if we wanted to allow cutting and ripping, we'd have to do thousands of tests where we basically cut 2x4 to 2x12 in a number of different configurations and test it. And the other issue that they have, even if we were willing to do that, is this: we're not in the lumber grading business. So if you have an application where you've got, let's say, something carrying a load and it needs to be a high grade of material, like a dense select structural to carry the load that you need. Essentially, and I don't know how much understand, I can't see and talk to everybody, so I don't know how much understanding people have of lumber grading, but the short story is this: it's based on allowable defects in a piece. So something like a knot or a crack or a defect will affect the grade. So there are more defects allowed in, let's say, a shop grade or a number 2 than there are in a number 1 or a dense select structural. So if I've got a dense select structural 2x12 and I've got a knot on one side and the other side is clear, and it meets grade, that knot in the size and number is allowable, but I center rip that into two 2x6s. Suddenly now I've got one on one side with a knot that's pretty big for that 2x6, but not for the 2x12. And that piece of DSS that I've now center ripped might be one piece that's a shop grade now because of the knot, and the other piece is now a dense select structural. So that's kind of where we land with center ripping. You can buy the size you need, and that's what we recommend that a contractor does. The stamp. I mentioned earlier that it's a mandate and it's a requirement. With lumber in particular, the way that the machinery is configured in a treating plant, we can only stamp the ends of it. So the lumber gets cut. If it's cut and the stamp is not there, again, there's a colorant on the material, generally speaking, but if an inspector knows what he's doing, they'll want to see the stamp. If the stamp's been cut off and you get a phone call stating that it's an emergency, they're going to red tag the job site. It's not really that big of an emergency. There's a chemical reagent we can put on the wood that will turn a color in the presence of the fire retardant treatment I can get personnel out to a job site to test it in the presence of a building official if need be, but there are ways around this. The point I'm making is if you run into this, call us, we can solve it for you. I've got a pretty good record. It's 100% basically. All right. I talked about tinting already. Strength reductions. When you pressure impregnate and kiln dry wood, there's a reduction in strength. All right. A code mandate for fire retardant treated wood is that we test the wood and derive strength reduction factors according to a couple of different ASTM test methods. All right. Those strength reduction factors are published on our website, published in UL's database. They're on our ICCES report. And the same would be true of any other fire retardant formulation out there. So my point is, while it seems like, hey, it's weakening the wood, that's a problem. The strength reductions are very small. In some cases, only about 1%. The industry average, depending on the attribute, is about 5 to 7% total, and that's kind of the ceiling. So the data is very, very exact. The testing is, again, done per an ASTM set of test methods. It's something that you can use for your design. So it's really not a handicap, although the coating manufacturers that aren't fire retardant treated wood harp on that as I don't know, the weakness of fire retardant treated wood, when the reality it's just a fact that you use in your design. Attic space ventilation, you'll see in just about every manufacturer's warranty that an attic space needs to be adequately ventilated. The issue there is only in an attic space that is designed to have soffit vents and some type of ventilation like turtleback or ridge vents, where that space is being used to move moisture out of that space from the living space below. If adequate space or ventilation was not there, the soffit vents were blocked up, moisture was allowed to accumulate. Things can happen to plywood products, treated or untreated, like buckling, warping, twisting, things of that nature that we don't want to happen. So that's the basis of those statements when you see it. And again, that's a very long conversation. If you have more questions about it, reach out to me afterward. All right, let's take a look at where it's used in construction. And I think everybody on this call is aware of the 5 types of construction, and I know there's subtypes, but again, for the sake of this presentation, since we don't have a ton of time, I'm going to kind of blow through these really fast, and I'm not going to get into the subtypes. All right, type 1, fire-resistant construction, high-rise, concrete and steel, or some other non-combustible material. All right. Fire retardant treated wood is allowed for use in a type 1. So where you'll see it typically, and I'll show you photos, would be, let's say in a high-rise building where it's got penthouse apartments and somebody buys that block where it's unfinished and they want their own floor plan. You can frame the interior partition walls out of fire retardant treated wood. The other place that you'll see it is purlins between steel studs or blocking, let's say in a computer, electrical, or telephoning room, where you're going to have conduit and things screwed into the wall. Wood's a great anchor for a fastener. And in this case, it has to be fire retardant treated wood because it's non-combustible construction. And this is a good time for me to point something out. Fire retardant treated wood is still a combustible material. It's a piece of wood, right? We put a formulation in it that reduces the spread of flame. But if we hold a torch to it, and as you saw in that test photo I showed you, if it's exposed to a fueled fire from another source, like a blowtorch, for example, as long as I hold the torch to it, it'll be consumed by the flame. If I pull it away, it'll self-extinguish. So it's not a source of fuel to start a fire or spread a fire around, which is the basis for its allowance in non-combustible types of construction. So the language in the code is it's allowed for use in lieu of non-combustible materials. All right, type 2, still non-combustible materials or non-combustible construction, kind of like type 1, only instead of going up, we're sort of going sideways and going out, right? And I think everybody can tell that's a target by the big balls that are on the concrete in front of the structure. But Targets, Walmarts, grocery stores, schools, things of that nature, there's a lot of fire retardant treated wood in these structures. This particular one, the marquee where it says grocery, That one's a little big, so I doubt it's framed completely out of fire retardant treated wood, but it could be. You'll see marquees like that on type 2 that are framed or at least skinned with fire retardant treated wood. And the idea there is, one, it's easy to frame it, and two, the signage, if it ever changes, you've got wood underneath that exterior fascia where it's easy to anchor something. Trying to think, what else did I want to say about this? Oh, in addition to that, the interior of a Target or a Walmart, for example, the wall is full of fire retardant treated wood. They've got racks, hangers, things that are mounted to the wall. And again, wood is a great anchor, but non-combustible construction. So it's got to be fire retardant treated wood. All right, type 3 ordinary construction. So my assumption here is a lot of you join this to talk about, or at least learn a little bit about type 3 construction. Hopefully you've got some projects in the hopper, or you've designed some. This particular, and we'll look just really fast at the code language here in a minute, the exterior walls of this have to meet, for the most part, two conditions. One, an hourly rating or an hourly penetration rating, something tested to ASTM E119. In addition to that, if you want to frame it out of wood, those exterior load-bearing or non-load-bearing walls will have to be framed and sheathed with fire retardant treated wood. All right, heavy timber, we won't talk much about this. It's pretty obvious. There's some applications for fire retardants to be used in heavy timber type 4, but some of you may know this. For the most part, a heavy timber, just based on its mass, gets a 1 hour rating. And again, if you want more info on that, contact me afterward. But I just want you to know it's here, and I want you to know fire retardant treated wood is allowed for use in type 4. Type 5, really no applications for fire retardant treated wood. If most of you live in a big apartment building or a single family home, I think you know this, but we live in the least protected, least fire resistant type of construction. We try very hard to try to get some passive fire protection in place that would include fire retardant treated wood on the code development side, but it's a tough fight. We generally get killed by the concrete and steel guys, and people representing contractors, or somebody that doesn't want to see the expense of a single or family home increased. And I get it, you have to be careful, you have to balance safety versus cost, but again, we all do live in the least fire resistant, least protected type of construction. All right, fire retardant wood in type 3 construction. So this is an actual passage out of the code, 602.3. And what I've highlighted here is that passage that allows fire retardant treated wood to be used in those exterior walls. So typically, before we had this allowance inserted into the code, the exterior walls of a type 3 multifamily like that would have to be non-combustible. So it would need to be some configuration that would include probably steel studs and drywall, and then some type of cement board, like a Den's glass product as the exterior sheathing, if you had a shear issue, or some other thing that you were designing where you needed some structural rigidity. So after we were able to get this into the building code, and we did this based on that statement I told you about earlier. Prior to this, fire retardant treated wood was mainly used in those type 1 and type 2 applications, or maybe in a roof system somewhere. So that in lieu of non-combustible material statement was part of how we began this conversation on the code development side and ended up here. All right, and this is another section of the exterior wall 705.5 statement, and the highlighted section that I've got here is essentially a statement that most of you probably recognize. If you've got an exterior wall in one of these type 3 structures that is essentially has a separation. Sorry, I locked up for a second. A separation distance of 10 feet or less. Either it's adjacent to another structure, or it's adjacent to a lot line. You're going to have something that's 2 hours rated from both sides. And I'll show you later, but we have a configuration that will meet that requirement. All right, I'm going to kind of blow through this. This becomes a presentation all on its own, which I can do if you need some heights and areas brush up. But the point I want to make is this. if you can kind of turn it into a type 3, and I know space is kind of an issue when you're looking at type 5 versus type 3, you get that extra story. And again, you can still frame it out of wood. So the heights are greater in type 3, and you can still frame out of fire retardant treated wood as opposed to going to non-combustible. And then here you see that type 3A, type 3B exterior wall, fire retardant treated wood is allowed for use. Type 5, you see no requirement for fire retardant treated wood. Again, least protective, least fire resistant. It would just be untreated wood. All right, fire resistance ratings. We're going to blow through this very, very fast. We're getting close to the end here. There are a few ways to arrive at an hourly rating for an assembly. The tabular method, which you're probably aware of by testing, and this is what's mostly done nowadays. An assembly of some type tested in accordance with ASTM E119, and we'll look at that test here in a second. Another option is the CAM method, the calculated method. If you're not aware of that, just let me know. There's a tech note I can send you, but essentially what you're doing is taking the known fire resistance ratings published in the back of the IBC for various things like a 2x4 stud wall or drywall, and you're adding up the time, and theoretically you come up with a system on your own that would meet a particular hourly rating requirement. All right, so this is what an ASTM E119 test looks like. All right, what you see on the left is a big box. Now that box penetrates and extends outside that wall. That's the exterior wall of the test facility. They want the majority of it outside just in case bad things happen. What you're staring at is a wall system being tested. You can see the 9 thermocouples that are stuck on the outside. Hopefully everybody recognized that as drywall, right? So you see the tape and mud, and you see kind of a little brown stripe in the middle of that. So that's the flame front about to destroy and penetrate through that wall. And if you look down at the far right, you see the clock at 58:09. So I'm getting pretty nervous here. I'm trying to get to 60 minutes. On the right, you see after the test, the test personnel, which always makes me nervous, moving that frame out from that box. All right. So I kind of saved the description of what's in the box until you focused on that photo. You can see that that wall is burning on its own. Inside the box is basically just a bunch of burners that blow and blast onto that wall, fans that move the flame front onto it. The idea is to completely destroy this thing and time how long it takes. All right. In addition to making it past your time threshold, which might be 30 minutes, 60 minutes, 2 hours, after they move that test frame out, they hit it with a fire hose. It's called the fire hose stream test, and that's part of ASTM E119. So the idea is to basically prove that that wall could still carry the same load that it's being tested for after it's met its hourly rating requirement for burn through. So very, very destructive test. It's expensive to do. But you get a lot of great data out of a test like this. And again, if you see an assembly tested to E119, you can bet that it's been very rigorously tested and will perform the way that that test report says it'll perform. All right, hourly rated wall assemblies. So I mentioned before in a type 3, you can frame the exterior load-bearing or non-load bearing walls of that particular type of construction out of wood, but if you do, it's got to be fire retardant treated wood. So that code change that we looked at caused the fire retardant treated wood industry to come up with wall systems and test them in accordance with ASTM E119. So our particular formulation, we have 5 different configurations, from 1 hour one side all the way up to 2 hours both sides. They're individual listings done through Intertech. I can send those out to you. I know everybody recognizes UL. We choose Intertech because Koppers is a great big multinational chemical company, and we have a better relationship with Intertech worldwide. UL is more US based. So just know that an Intertech listing is equivalent to a UL listing. They're both test reports from a testing lab at the facility where the test was done. They're equivalent. I can write you a letter, describe it to you. I get questioned about that a lot. So let's just kind of look at some uses or what it looks like in actual application. This is type 3, but on a podium. So at the bottom of this, you have either one floor or two floors that are non-combustible type 1. And this mixed use was something that, basically designed to allow for retail or parking space below, and then a more cost-effective way to frame the living space or the residential above it. All right, the Texas donut. This is also a type 3. This is kind of an interesting way to have looked at type 3, but what you see here is in the center a parking structure that goes all the way down to the ground floor. So you've got type 1 concrete and steel surrounded by type 3. So the architect that came up with this, the idea for him is that somebody could park on the floor that they lived in, get out of their car, and not walk a very far distance to get into the unit they lived in. It requires a lot of area to build something like this, but again, kind of creative way to look at a type 3. All right, just another photo of a type 3, but notice in these two photos that exterior wall doesn't always have to be flat, right? You can have bump outs. The right-hand photo, those aren't balconies. Those things end up getting covered with a WRB and then like a cement board and a decorative sheathing, and they were meant to be kind of things to set plants on. But in any case, because it's part of that exterior wall, that had to be fire retardant treated wood too. All right, here's another example of a type 3. On the left, you can see the colorant and the material on the exterior framing. But if you look inward to the interior partition framing, you can see that's not fire retardant treated. So again, on these type 3 projects, it's just the exterior wall, the load bearing or non-load bearing exterior wall that has to be fire retardant treated. The right-hand photo I bring up because this was a mistake by a contractor. He didn't pay attention. So type 3, but if you look at the sheathing, you can see that it's a mixed bag. There's some OSB, there's some fire retardant treated wood, there's some untreated plywood. All of that should have been fire retardant treated wood, every bit of it. So what happened here is that the building official called foul, and a couple of us from a couple different manufacturers had to come out, identify our material because he mixed manufacturers on the fire retardant side, and essentially ended up having to rip off the untreated material and cost him a lot of time and a lot of money. But I show this to also bring up the fact that if you do have a problem on a job site, somebody like me will come out and help you solve it. So don't think you're on your own. Contact us. We'll do what we can. Again, I've gotten pretty creative over the years. I've got a pretty good record of solving problems like this, and they happen. So just keep in mind, it's not the end of the world. All right, roof sheathing and trusses. This is a really popular application, historically speaking, before the type 3 allowances. In this case, this is actually a hotel. It needs to be like a nice homey pitched roof. That's the idea with a lot of hotels. The trusses are fire retardant treated wood, but they could have been steel. However, it still would have had to been sheathed with something. And because this was classified as a type 2, it had to be fire retardant treated wood. In this case, there's an allowance in the code where if the trusses are fire retardant treated wood, you can avoid having to sprinkler the attic space. So that's why the trusses ended up being fire retardant treated wood as well. All right, this is that purlin or inside the wall application I talked about earlier when I mentioned the Walmart or the Target. So this is what it would look like. In this case, this formulation wasn't colored, but if you look around, you'll see stamps in various places. All right, another wall sheathing application. In this case, this is not a tested assembly of ours. It includes steel studs. All of our assemblies include wood studs that are fire retardant treated, but this manufacturer wanted to use fire retardant treated wood. So they used the CAM method that I told you about and used fire retardant treated wood sheathing on the outside and kind of developed their own hourly rated system. This material was made by a company that doesn't choose to tint the material. So this, appearance is just as if it's untreated wood. All right, and here's that interior partition wall framing that I told you about in type 1 or type 2. All right, and this last photo, this is a concrete and steel building, but if you look at those window openings, you'll see wood in the surrounds. All right, again, wood is a great anchor for a window or some other thing that you're going to mount in that space. So fire retardant treated wood is used very, very often, particularly in a window opening like this, to anchor the fastener. All right, here is the only application for fire retardant treated wood listed in the International Residential Code. All right, and this is kind of a weird photo because they extended that Densglass product up through the opening and they're going to cut it off. But if you look closely, you'll see fire retardant treated wood in what amounts to a minimum of 4 feet of either side of that fire separation. So what this allows you to do if you're designing a flat row of townhomes, you can omit the old parapet requirement where you had to extend the fire resistant wall all the way up through and have it come above the roof sheathing. In this case, you can do a flat roof, omit the parapet, but you have to have fire retardant treated wood 4 feet of either side of that fire separation. All right, we're going to get through this fast because I've run over. All right, a building code compliance report. There are a number of places that issue these things. What it is a third-party report that proves code compliance for a particular product for a given set of code requirements. I highly recommend that you only specify products that have building code compliance reports, and ICCES is the most popular. All right, I just told you what one was. We're going to go past this. All right, and I want to point something out. If you don't know this, a building code compliance report is not a mandate or not mandated or required for code compliance by the building code. It's just a nice third-party report that is done by a certified, somebody like ICCES agency that reviews it and basically writes down in that report that it's code compliant for the applications the manufacturer says it's compliant for. All right, if I come up with a new product or a new way of doing something that's not addressed in the building code yet, and if you don't know, the building code is updated based on a 3-year cycle. I can't get a building code compliance report yet because my method or my product's not addressed in the code. I'm still working on it. I can approach ICCES and I can ask them for an evaluation to create an acceptance criteria. So that would be a way to produce or build something that's been reviewed by ICC evaluation services, not yet recognized in the code, but something that's expected to be. And the report they issue is a set of instructions on how to make a product that would be code compliant, and they certify that. So if I've got a new product or method, I can approach them and essentially have this acceptance criteria done, and then I have to produce to it to be code compliant. If you're dealing with a product that does not have an active ICCESR report or some other code compliance report, check to see if there's an acceptance criteria. And if there is, ask to see it. If there's not, I would be very, very dubious about the code compliance of that product. All right, fire retardant coatings in the building code. All right, the IBC essentially does not allow sprayed on or site applied products to be allowed for use in fire or applications where fire retardant treated wood is required. What you see here is the actual verbiage from the building code. The use of paints, coatings, stains, or other surface treatments is not an approved method of protection as required in this section. That section is straight out of the definition of fire retardant treated wood. I've got emphasis added because not is actually highlighted in the building code. All right. If you're familiar with the code, you know that it's not very often they tell you what you can't do, right? It's generally a minimum set of standards where they tell you what you can do or how to do it. We don't make a habit in the building code when we write it of telling you what you can't do. So my point here is this is very serious, and we took it very seriously when we wrote this verbiage. All right. There are coatings out there that will tell you that they're new and innovative. Don't fall for that. All right. What you want to do is ask for their code report. You want to look at it and make sure that it's code compliant for Chapter 23 fire retardant treated wood applications. Again, the method of application makes a difference. Now, I want to point something out to you. There's other verbiage in the building code that states that a topically applied product would be allowed for use if it's an integral part of the manufacturing of the product. So there's a product called Flame Block made by LP. So this is a topically applied product over OSB that is code compliant for fire retardant treated wood applications, but it's also made in the same factory on the same line that the OSB is made on. So that cementitious fire shield, that if you go look at that product, you'll see that's what it is done in the factory during the same manufacturing process as the OSB and is certified by third parties. All right, so that topically applied product, and it's like a slurry that hardens, is allowed for use in the code. All right. Coatings that are sprayed on in a factory when they basically ship lumber or plywood in, and they're water-based coatings that are out there that'll tell you they're fire retardant treated wood, are not allowed for use in fire retardant treated wood applications because they're not done in the way that LP does it, where it's on the same line in the same factory as an integral part of the manufacturing of the wood product in total. All right, so in summary, fire retardant treated wood, you got a minimal flame spread, reduced smoke developed, reduced heat release. It's self-extinguishing, so allowed for non-combustible types of construction because it's not a source of fuel to start a fire, spread it around. So that equates to the statement, no progressive combustion, meaning that it won't light on fire and spread fire around on its own. All right. Has to be pressure impregnated or an integral part of the manufacturing of the wood product in total. Has to be third-party monitored throughout the entire process. All right. It's species specific. So if you run into a product that says I can spray anything and it's fire retardant treated wood, don't go there. All right. Reduced insurance rates. That's a possibility in some structures. That's another conversation. We'll talk about that now. Product is readily available. You can get it at any building product manufacturer or any building product supply. You can get it at Lowe's, Home Depot. You can order it through them, any contractor yard. And again, it's available, treated into any species that's used for construction throughout the United States. All right, that's all I have. Again, feel free to write my cell phone number down, take my email down. I left a lot out here. We had to do this fast, and I even ran over time, so I apologize for that. But contact me at any time. I'd be glad to help you out if you have more questions. Thanks very much.
Awesome. Thank you so much, Travis.
Sure.
All right. Yeah, it looks like we do have a few questions. I'm not sure we've got time to get to them live, but we have a record of all your questions. So we'll get that over to Travis. We'll get you followed up with. But yeah, before we jump off, just want to say thank you everyone for joining us today, for asking some great questions. There will be a quick post-event survey. If you've got any questions that are coming up as you leave the event, feel free to leave them there as well. We'll have all your email addresses so we can follow up with you after today's webinar.
And I'll get those questions answered fast for you.
Awesome. Thank you, Travis. Have a good one.
You too. Thanks.